So now let's consider two sample t-tests. So consider the two sample, and we want to see the sample mean they're different, right? Suppose a sample would be like class, right? We have people from one gender and another. We want to see whether there's difference between gender, or people who study in business school and study in say social science. Do they have same mean for certain thing or certain other thing? Then here we assume the population have same variance. Okay, next we'll talk about the different variance, but focus on the case where the same variance, and we want to see. So we focus on the two-sided test, but you can easily adapt it to the one side with the knowledge you have learned for the one sample test. So then now are they the same mean for the two population, and now the alternative will be the difference. And what you get from the sample is two sample mean, x1 bar and x2 bar. Sample size n1, n2 n1, n2 need not be the same, can be different. So the test statistic is like this: is t, because we don't know the sigma, so it's x1 minus x2 minus mu1 minus mu2. So difference between the sample mean minus difference between the population mean. Okay. And on the x now, actually this is 0, and over the this variance of this difference, so it's SP pooled sample variance times 1 over n1 over n2 is distributed as a t distribution, n1 plus n2 minus 2. So why this is the case we'll explain later, but take it for granted. We'll explain why this is true. Looks very weird object. But first of all, what is SP square? SP square is another very strange object. N1 is you can see denominator is a weighted average, right? The denominator is N1 minus 1, N2 minus 1. So it's N1 plus N2 minus 2. And it's N1 minus 1 and N2 minus 1. So it's, and S1 and S2 is the sample, as we see here, right? Is the sample variance of group 1, sample 1 is group 2. Okay, so the SP square. So critical value will be plus minus, right? Because it's two-sided. Okay, N1 plus N2 minus 2 is half over 2, right? And the same idea for the confidence interval estimator, right? N1 plus N2 minus 2, half over 2, right? And this is what we have here. This is something you would have understand. If this is distribution like this, then this will be the natural confidence estimator. Okay, let's see example before explaining why this is true. So two population, same population variance. Either one random sample from a population with sample size 50, sample mean is 40, standard deviation is 4. Another random sample from another population, right? Is sample size 40, sample mean 42, and sample standard deviation is 3. The null is the same, the not equal to. Okay, so calculate the pool the variance. Okay, so calculate the SP. Okay, is 50 minus 1, right? And 50 minus 1 for the minus 1, 4 square, right? And 3 square, right? 4 square and 3 square average is pooled. It's average in this way. And the next is calculate the t. Okay, the t stat is 40 minus 42, right? Pooled in this way times 1 over 50 plus 1 over 40. Okay, and it's negative 0.26. Look at the t table, right? It's 88, right? Degree of freedom, because 50 plus 40 minus 2. Okay, we use 5%, so it's 0.025, so it's 1.98. Okay, so the t, the absolute value t, okay, or t is this value, right? So it's less than the critical value, right? So it's more extreme, so we reject. 2 times of this 2.65 is also 0.001, so it's much less. Okay, it's 0.05. So the confidence interval, right, is the t value, right, times the denominator of the statistic, right? So that is something easy to calculate. Okay, just calculator. So why that is t n1 plus n2 minus 2, right? So first, we'll show these two statements, right? This is the difference, right? And if we know the sigma, right, this n1 over n2 will be the normal, and this particular guy, okay, very complicated guy, but it's sum of square, right, over the sigma will be the chi-square n1 plus n2 minus 2, okay? So first one is straightforward, right? The difference between them, right, variance of 2 part, right, is plus, so it's a variance of 2 sample mean, right? So it's sigma square over n1 and sigma square over n2, so that is what we have. So that first one will be easy, right? So that is a standard normal, right? Because this have a x bar, right? We have x bar is a normal distribution, right? So that's, and second, this part, how to prove this? Okay, first is sum of square over n, right? Sum of the x over sigma square, right? Because it will be n1 minus 1 s1 over square, right? Sigma square. So this is coming from previous chapter, right? It's n minus 1, right? S square over sigma square. Okay, this is same. Okay, coming from what we learned from the previous chapters. So because x bar and si are independent, right? So that's why you can rewrite it, what we have here, right? This particular crazy thing, right? This test statistic, right? Is x1 minus x2 minus x bar, which is 0, right? So x1 minus x2 over the sigma over this guy, okay, which is z. The numerator is z, okay. The denominator, okay, which is this, right? This is pooled variance, right? And sigma square cancel all the sigma, right? The sigma, but this guy is actually the chi-square distribution, right, over its degree of freedom. So that's why this is t distribution.